If you're working with Angular, you know the deal. Change detection can sometimes feel like a real performance headache. Well, today we're talking about Angular signals, and this isn't just a small tweak, it completely changes the game for how Angular thinks about reactivity. It's a huge deal, so let's just dive right in.
So here's the plan. First, we're going to talk about the problem we're all trying to solve, that classic reactivity challenge. Then, of course, we'll introduce Angular signals as the hero of the story. We'll get our hands dirty with writable and computed signals, which are the two main tools you'll be using. After that, we'll tackle effects, and trust me, there's one major pitfall you absolutely need to know about. And finally, we'll wrap it all up with the big picture so you can walk away ready to use this stuff.
All right, so why bother with a whole new system? Well, for a long time, Angular's way of handling updates was, let's just say, a bit aggressive. It was kind of like flipping the main breaker for the whole building just to turn on one lamp. A tiny piece of data would change, and Angular would have to go check the entire component tree to see what needed updating. I mean, it worked, but it was often a whole lot of extra work.
And that really leads to a question you have to ask yourself, right? Think about your own apps. When one little thing changes in some corner of the UI, is your whole app doing a bunch of unnecessary work? Are you re-rendering massive component trees just to update a single label? That's the exact inefficiency that signals were designed to just eliminate.
And that brings us to the solution, Angular signals. It's a total shift in thinking. Instead of that old check-everything approach, signals give Angular the power to make updates with, surgical precision. So what is it really? Well, you can think of the whole signal system as a brand new engine running under the hood of Angular. And its one job, its only job, is to know exactly which part of your UI cares about which piece of data. No more guessing. No more overchecking. Just clean, optimized, and super fast updates.
And the core building block of this whole system is this signal itself. Just picture a little box, a wrapper that holds a value. But here's the cool part, this box has a superpower. The moment the value inside it changes, it sends out a little notification to anything that's listening and says, "Hey, I'm different now."
Okay, so the theory is cool, but how do you actually use this stuff? Well, in your day-to-day code, you're pretty much always going to be working with two main types of signals, writable signals and computed signals. And getting the difference between these two is absolutely key to making it all work. And the difference is actually really simple, but it's super powerful. Think of it this way. Writable signals on the left are like your raw ingredients. They're the sources of truth that your user or your app can directly change. Computed signals on the right are like the final recipe. They are values that are derived or calculated from those raw ingredients. And making a writable signal? It could not be easier. Seriously, you just call the signal function and give it a starting value. Right here, we've just made a signal called count and started it at 0. That's it. You've officially created a piece of reactive state.
All right, so you've got a signal. How do you change it? You basically have two methods. You've got .set, which is like taking a sledgehammer and just replacing the old value with a completely new one. And then you have .update, which is much more precise. It gives you the old values so you can figure out the new one. Perfect for something like, incrementing a counter.
And that brings us to the other superstar, the computed signal. Just look at this line of code. We're creating a new signal called double count. Its value is calculated by a function that uses our count signal. And notice that to get the value out of count, you call it like a function. Here's the magic. From now on, whenever count changes, double count just automatically updates itself. No extra code, no listeners, nothing. It just works.
Now this is where things get really, really clever. Computed signals are incredibly efficient. First, they're lazy. That means they do literally zero work until some part of your app actually asks for the value. Second, they're memoized, which is a fancy way of saying they cache the result. If nothing is changed, they don't recalculate. And third, their dependencies are dynamic, meaning Angular is smart enough to know what to track on every run. It's just so efficient.
Okay, so we can create state with writable signals, and we can derive new state with computed signals. But what if you need to do something in reaction to a change? Something that isn't just creating a new value, like logging something to the console or syncing with local storage? That's what we call a side effect, and for that, we have effects.
Now, effects have a very specific, very narrow job. Think of them as your escape hatch to the outside world, the world outside the nice, clean signal system. Anytime you need to do something that isn't just about state, like sending analytics, saving data, or doing some manual DOM stuff that Angular templates can't handle,
That is a perfect job for an effect.
Okay, I need you to lean in for this part, because this is probably the single most important rule you need to learn about signals. There is a huge anti-pattern here, and you really need to avoid it.
This is so important, it comes straight from the official docs. It says, avoid using effects for propagation of state changes. Let me translate that for you. You should never, ever write an effect that changes another signal. Don't do it. If you find yourself wanting to derive a new state value from an existing one, that is always the job of a computed signal. Always. If you break this rule, you're asking for bugs and nasty infinite loops.
Okay, phew, that was a lot. Let's zoom out and pull everything together. If you're going to take away just a few key things to remember for your next project, these are the ones. So let's lock in these 4 golden rules. 1, granular tracking. You get amazing performance pretty much for free. 2, clear state management. Writable signals are your source, computed signals are for values you derive from that source. Simple. 3, effects are for side effects only. Do not use them to set other signals. And 4, don't overthink it. Let the framework handle the dependency tracking. That's its job, and it's really good at it.
And that kind of leaves us with a really exciting final thought. For years, we've had to architect our apps around the way change detection worked. We had to be careful. But now, that constraint is basically gone. With a reactive model this precise, this efficient, what does that unlock for you? What kind of complex, high-performance things can you build now that maybe felt impossible before? It's a whole new world. Go build something cool.